Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Stefan Mapotsani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12, in today's lesson, we are focusing our attention to trigonometry. So we are dealing with the revision for trigonometry. And remember, trigonometry takes 33% of our paper 2. So we need to really get those marks and get that 33%. Now, for this lesson, grade 12s, we must be able to revise the topic of trigonometry as it is found in paper 2. We are saying for trigonometry, remember, we revise the trigonometric concepts that are learned in earlier grades, which are reduction formulas, special angles, identities, and the general solutions that we've learned in grade 10 and grade 11. Number 2, we are revising the compound angles and double angles as we have done them this year in grade 12. Number 3, again, we are revising the trigonometry in 2 dimensions and 3 dimensions that include both the concept from grade 11, 10, and 12. And we're going to revise our trig functions as they come from grades 10, 11, and 12. So this information comes from our CAP document on page 42 and page 43, and it is also stipulated in our ATP for 2025. Now, these are the topics for paper 2, and we can see our trigonometry there. It's sitting nicely at 33%. So it is the one that takes the majority of paper 2. So we can see it is the highest in terms of percentage. So it is plus 50 plus or 3 marks or 50, 53, somewhere there. And it has 3 questions, question 5, 6, and 7. And we must remember that the trigonometry also have proofs, and the proofs and of geometry, or all of the proofs, including the trigonometric proofs, are amounting to the minimum of 12 marks. So the proof on geometry and the proof on trigonometry, they must give us the maximum of 12 marks. Trigonometry. In most of the cases, we have question 5, 6, and 7. Remember, it's not really fixed this way. It can be, they can place them the other way around, but most in question 5, this is what is happening. In question 5, there are 5 types of questions that we are testing you on when looking at question 5. We are looking at the first one, using the diagram on a Cartesian plane. We are going to draw a right angle triangle to solve without using a calculator. This is the question that will mostly say if sine beta is equals to 1 over 3, we give a restriction to say solve without using a calculator. We are going to represent this on our Cartesian plane. So that is the one that utilizes the diagram. Number 2, we are going to say the second type of a question says simplify the trigonometric identities. Number 3, we are going to solve the equations, trigonometric equations. In most cases, we are dealing with the general solution with regards to the equations. Number 4, we are going to prove a trigonometric identity. 5, we are problem solving, and where we are going to apply the nature of roots on our trigonometry. So those are the 5 type of questions that are there on question number 5. This is one question. So this could be question 5, 6, or 7. It doesn't matter, but it's on one question. Use of a diagram, simplifying identities, solving the equations. Mostly we are using general solution, proving the identities, and we are dealing with the problem solving questions. Right. Let us now have a simple revision on trigonometry. We need to remember SOHCAHTOA. These are the definition. In a right angle triangle, we are using SOHCAHTOA, where sine theta is equals to opposite of hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And these are represented on a Cartesian plane as sine theta is y over r. Then this is our diagram that we are looking at on a Cartesian plane. Cos theta is x over r, and our tan theta is y over x. And we must also remember, on a Cartesian plane, we must be able to utilize the concept of a Pythagoras theorem. Then we must remember cast rule. So you can see the cast is C-A-S-T. Then we can say all trig ratios are positive in the first quadrant. It says all. Then sine theta is only positive in the second quadrant. So the student is all students take care. It says all students take care. Then tan is only positive in the third quadrant is the take. Then cos is positive on the fourth quadrant is the k. Then we're going to look at the concept of reduction formula. Reduction formula says quadrant 1 is 0 plus theta, where all of them we can say when you say 0 plus theta, they are all positive. Quadrant 2 is 180 minus theta. Just want the diagram. So quadrant 2 is 180 minus theta, and only sine is positive. Then both of the cos and the tan are negative. So that is 180 minus. So it falls in the second quadrant. Third quadrant is represented by 180 plus theta. 180 plus theta. Remember, this is all student take care. So we are saying only tan is positive. We are seeing on the third quadrant, tan is positive nicely there. Then on the fourth quadrant, k is for cos. Then we are saying only cos is positive. So that is very much important for us to look at right there. And remember, our fourth quadrant, it also works with our negative angle, where we are now changing the direction on the negative angle, going in the clockwise direction. When you're looking at a negative angle, it falls on the fourth quadrant. That's why even when you're dealing with a negative or a cos into a negative angle, it becomes a positive cos. But the sine into a negative angle, it becomes negative sine theta, and the tan into negative angle, it becomes what? It becomes negative tan theta. So cos is positive when we are dealing with the negative angle as it falls on the fourth quadrant. Right. Let us move on. So we are also going to look at the co-functions. Remember what are co-functions? Co-functions are operating on where theta is plus. So this is co-functions. They are here. So theta is 90 minus theta. This is 90 plus theta. So that's why those are our co-functions. And also we are saying we have 270 plus theta and 270 minus theta. That are also co-functions. Then we are saying when we are working with a reduction formula where we have 90 minus theta, 90 plus theta, 270 minus theta, 270 plus theta, the ratio changes to its co-function. Then what are the co-functions? Then we're saying the co-function of sine is cos, then the co-function of cos is sine. So that is to say, if I have sine 90 plus theta, this is the co-function. 90 plus theta is a co-function, then the sine must change into a cos. Then 90 plus theta is on the second quadrant, then sine was positive here. So because sine was positive, then the cos will also be positive. Then when we look at the co-function where we have cos 90 plus theta, 90 plus theta, second function, second quadrant. Second quadrant, we are saying only sine is positive, so cos was negative. So the sine here is determined by the cos. So cos was negative. So that's why we have a negative sign there, because this is a second quadrant. Then what are we saying? That co-function of cos changes to sine. Then we have cos of theta, 90 minus theta is quadrant number 1. So all of them are positive. We are now saying cos changes to sine and the sine changes to cos. So those are the co-functions that we look at. Now we're going to look at identities again. We remember the square identity that says, sine squared theta plus cos squared theta is equals to 1. Then we are now saying we can just transpose, or we can subtract cos both sides. Transpose the cos becomes 1 minus cos squared theta. We can now work with cos squared theta equals to 1 minus sine squared theta. So this is going to be guided by our question as to how we want to simplify the equation. Then we're going to look at the quotient identity. The quotient identity, we are now looking at the tan identity, which says tan theta is equals to sine over cos. Then we say 1 over tan theta is going to be cos over sine, is going to be the reciprocal of that tan theta. Right. Then we are also looking at compound angle identities. Remember, These identities are provided to us on our formula sheet. Then we must remember that sine into x alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Then sine alpha minus beta, it is what? It is sine alpha cos beta minus cos theta cos alpha sine beta. What you see on the sine, the sine remains the same. So the sign remains the same. Then on a cos, the sign is going to change. Sign remains the same, but the angles are together. They are changing nicely there. Sin and cos, sin and cos. Then on a cos, we are having the sign changes. Then it's cos, cos, sin, sin. So sign changes, the angles are the same, or the ratios are the same in that case. On the sign remains the same, the ratios are multiplied differently. So that's what we are looking at. Then we're going to focus our attention to double angle. Then the double angle for sine 2x is only 1. It is 2 sine x multiplied by cos x. Then we are also looking at the double angle for cos. The first one we can use, it is cos squared x minus sine squared x. Or we can use the one of saying cos 2x equals to 1 minus 2 sine squared x. Or when we have the cos 2x is equals to 2 cos squared x minus 1. So it will depend on which one it is favorable for or per the question. Now, let us now start looking at the first question when we are working with the diagram on a Cartesian plane. When we are dealing with the diagram on a Cartesian plane, the question states, when a question states to be solved without using a calculator, what are you supposed to do? Number one, an expression for a value of one trigonometric ratio is given. Then that is to say, maybe they will say sine beta or 2 sine beta is equals to 1. So they're giving us the value of that trig, a one trig ratio. So that is the sign in this case is given. We are going to use the right angle triangle on a Cartesian plane to determine and express the values of the various trigonometric ratios and expression. What are we going to say again? The question will state the size of one angle. So this question will give us the size of one angle, and the question relies on you drawing that triangle. And what's important when you draw the triangle you draw, it will always be a right angle, meaning one angle will always be 90. And if you want to know the third angle, it can be calculated by using the sum of angles in the triangle. Let me go back to my example there. So what we normally do here, we're going to say divide by 2. We separate the ratio and the values there. So sine beta is 1 over 2. We are going to look for quadrant where sine is positive. Remember, the restriction is going to be given for us. Where sine is positive, we go on a Cartesian plane, is 1 and 2. So the right angle triangle can either exist on the first or the second. Then remember, we're going to apply the definition of a sine. It is y over r. So the y value is 1, then the r, which is the hypotenuse, is 2. That is how we're going to work with it. Let me just throw it nice so that we can be able to see. So the one diagram will fall here. Second, the other diagram either will fall there. Then y, because this is sine, over r. Our r is 2. You can see 1 correspond to those that way. So it's 1 and 2. So it will depend on our restriction as to which one we take. That is our 90. This is our theta. If we want that angle, we use the sum of angles in a triangle. Then we can be able to find this value of x using Pythagoras. So that is how this question it is being analyzed. Then we say use Pythagoras theorem to calculate the length of a third side. So if you are given two sides that we did, it was 1 and 2, then you can use and find x, or you can be given any, then you can find a third side that way. Right, grade 12. Now we have question 5.1. So for this question 5.1, you are given only 6 minutes to complete this activity. Welcome back, grade 12. Let us now look at this question where we are dealing with the diagram on a Cartesian plane. We are told, we are given that root 13 sine x plus 3 is equal to 0, where x is an element of, so they gave us the restriction. So what are we supposed to do when we have a question like this? We need to analyze this question. So we have root 13 sine x plus 3. We need to separate this trig ratio to be on one side. We're going to deal with that 3. We're going to have root 13 sine theta, sine x is equal to negative 3. We divide by root 13 so that we can have the trig ratio separated alone. Then we see that our sine x, it becomes negative 3 over root 13. Now, what do we do from here? We're going to plot this on our diagram. How do we plot it on our diagram? We can see it says root, it's negative 3 over root 3. What does it say? 13, not 3. Well, it's just root 13. Right. It says where sign is negative. You can see that this has a negative sign. So sign is negative on the fourth and the third quadrant. Now, where do we choose, or how do we choose which quadrant we're going to use for this question? It will now depend on the restriction. Our restriction, it says we are saying x is an element of 90 to how much? 270. So it's from 90 all the way to 270. We can see that the fourth quadrant is not within the restriction, so we can't draw our triangle on the fourth quadrant. The restriction, now we are remaining with the third quadrant. We draw the triangle, write them, we plot in the values, then we go back to the definition of sine. Sine, it says, is y over r. Then what is y? Y is going to be negative 3. So y goes to the negative 3. That's why we plotted negative 3 there. Then what is our r? Our r is root 13. So when r, it corresponds with root 13 there, then r is root 13. Then we need to find the value of x there. So how would you find that value of x? We're going to use Pythagoras to find the x or the x coordinate. Then x equals to the root of r squared minus y squared. Then we square it both sides. Then x equals to negative 2. Remember, our x date was positive or minus 2, but you can see that our x is lying on the negative side, so it's going to be the negative 2. So we need to find that. Why are we doing that? So that we know what? We know our y, our x, and our r. All the time when we're dealing with the diagram on a Cartesian plane, always know what is our x, y, and r. Then we do that by plotting on a Cartesian plane and find the values of those. Now let us proceed. We now found x, y, and r. We can now find what? We can now work with our questions. So what we do now, 5.1 says 360 plus theta. We are going to start with the reduction formula on that one. So what are we saying? We are going to start by reducing 360 plus x. So 360 plus x, it falls on the first quadrant. Then we have, on the first quadrant is 360 plus x. So it goes on the first quadrant and sign is positive. So we're going to remain with that sine x. Then sine x already we know from our question is going to be given as a negative root 3 over 2. So that is our sine x in this case. Even when you are here, you can write all of the trig ratios if you need to. We can say our cos x is going to be x over, so it's negative 2 over root 18. We can write the 10x here. It's going to be opposite, which is y over r, which is 3 over 2, which is negative 3 over 2. But let's move on. Then find 10x, because we now know what is our values from our sketch. We know that 10x is equals to y over x. Then our y was negative 3 from the sketch. This was negative 2. So that is our 10x. Then we can now have that as a positive value, which is now negative divided by negative is equals to 3 over 2. Then find cos 180 plus x. what is 180 plus x to begin with? We need to start there. 180 plus x, it lies on the third quadrant. That is 180 plus x. Then cos is negative. So we are going to have a negative cos. So we're going to have negative cos x, because cos is negative. Only 10 in this case is positive. Then we have negative cos x. Then we are going to substitute our cos x according to the diagram. Our cos x according to the diagram, remember, cos, it was what? It was negative. From the diagram there, it was negative 2 all over root 13. Then it did a negative outside. So cos is going to be root, or cos is going to be 2 over root 30, which is now going to be positive, because the negative and negative is going to divide out. Now, let us look at the question tab number 2, where we are looking at trigonometric expressions and equations. So when you're looking at trigonometric expressions and equations, we are saying for these two types of questions, what do we need? The skills and knowledge we need for these two questions are the following. We need to be able to apply the reduction formula, including the concept of using the double and compound angles. Number 2, use the co-ratios, use the special angles, and use of identities in order to deal with expressions and equations. Now, specifically when we are looking at this trigonometric equation, remember the expression, we are dealing with it when they say solve for a certain trigonometric expression, or they say make it or represent it as what? As one trig ratio. When we are dealing with the equation, what are we supposed to do? We are finding the values that make the angles of the equation to be what? To be true. So it's just sin x is equals to 3. So we are now looking at the values of the angle, which is angle x in this case, that makes this equation to be true. So what is the values of x that will allow sin x to be 3? So that is what we are saying here. In most cases, this question is tested using the general solution. What is a general solution? It is a formula for all possible values of x that satisfy the equation. So with general equation, you must understand that this angle, it will have multiple values that are satisfying this equation. So we are saying, in most cases, this will be given within an interval. If it is not giving any interval to telling us between maybe 0 and 90 or 0 and 180, we are saying we'll provide all the solution from 0 to 36. So we're going to provide the solution for that equation from 0 to 360. So that is how we work with expressions and our equation expressions. We are just simplifying, and our equations, we are mostly dealing with a general solution. Now, grade 12 in front of us, we have a question there, 5.2 and 5.3. So for these two questions, you are given 10 minutes to complete these two activities. Welcome back, grade 12. Let us now focus our attention to 5.2 and 5.3. Let us look at this one. 5.2. 5.2, it was saying, determine the value of the following expression without using a calculator. Step number 1, application of reduction formula. When we apply the reduction formula, we are checking which ratios will use the reduction formula by knowing or checking which quadrant those fall in. So the first thing that we're going to do, we are going to start with the first one. We can see it needs to be reduced, and it falls in quadrant number 2. So this is second quadrant. I'm coming to this. Oh, this one, it is a negative. Right, so theta minus 180. So we need to change it nicely then. I'm going to use another method to change this. So we'll come back to it. Then we have the one into a negative angle. So when we now deal with the one on top there, which is cos into 90 plus, two things, second quadrant and a co-function. So we know that 90 plus theta, it is here, and cos is negative. So we're going to have a negative value or a negative sign because cos is negative and it's a co-function. Cos changes to sine theta, which is what we are having there. I'm going to just go straight to this one. When you go straight on to that one, what we have sine, trace sine into a negative angle, so it becomes negative sine. So that's why the sign changes to become negative right there. Then we are going to look at this situation here. We can take out the negative as a common factor. Then we change the signs inside and we swap them around. Or what we can do here, we can just say sine into theta minus 180. Just add the multiple of 180. You can add 360 here. Then what we see, when we added 360 to that, I'm just converting this, just using the simpler method. This can be a bit complex. Let us use this one. So it's going to be sine into theta plus 180, because that negative 180 plus 360 give us positive 180. This is just sine into 180 plus theta. Then you're going to reduce using 180 plus theta. You see now it is in a standard form. So what I was saying must be in that case. So what do we do from here? From here, we are going to find which quadrant can this be reduced with. We know that that is on which quadrant? 180 plus theta, it's here. That is the 180 plus theta. So this is quadrant 3. On quadrant 3, sine is negative, so it's going to give us negative sine theta. So which is why I have a negative sine theta right there. So it becomes easier when we deal what? When we just add a multiple of 180 to that question right there. Don't add the 90. 90 is going to do what? It's going to give us a co-function. So it's going to change everything. So you see, whenever we have a negative angle, then we add 360 or 180, which is a multiple of, which is our multiple of 180 right there. So that's what we did. We added 360 to convert that negative to becoming a positive. Then we see we have negative sine theta, which is what we have right there. So now from here, it becomes easy for us to do what? To proceed with our solution. Now, when you proceed with our solution, what do we now have? We have the following. These are like terms. So it's 3 sine theta, and it's actually more like, for example, let's say theta is x, sine theta is x, so it's negative x minus 3x. So we must be able to relate algebra to this kind of a question. So we can say sine theta is actually 1 sine theta minus 3 sine theta. Those are like terms. So it is 1, negative 1, negative 3, it's negative 4 sine theta all over. And on top is 3 sine theta. What you see there, it is that the sine theta and sine theta will divide out. Then negative 1 over negative 4, it's 1 over 4. The negative and negative will also divide out. So that is all about that question. And the mark allocation is 5. So do not be intimidated by that amount of marks. Because in most cases, with trigonometry, we are going to give you a mark for every reduction that you are going to make. Then it's 1, 2, 3, 4. So it's 1, 2, 3, 4. Then the fifth mark there, you see that to simplify there, to reduce every angle. So that is where the marks are many. Now, determine the general solution of the following equation. So to find the general solution of this equation, so what are we going to see? We are seeing that we are having a zero product rule right here. So if two brackets multiply each other, equated to 0. We are applying the zero product rule as we would under our algebra. So the first bracket is equal to 0 and the second bracket is equal to 0. So we're going to simplify and work with the brackets separately. So I'm going to just focus on one side first. What do? We can minus cos both sides. We remain on the left hand side, we remain with 2 sine x is equals to negative cos x. Then what do we do from here? From here, what we did is the following. What we did is we had 2 sine x is equals to negative cos x. We just divided both sides by cos x. We divide by cos x. we remain with 2 tan, because sine over cos is tan. It's equals to negative 1 divided by 2, Then our tan x was negative 1 over 2. So that is where we are right here. Then we need to find the general solution of tan x. To find a general solution, we need what we call a reference angle. Now, to find that reference angle, we are just going to say tan second function of 1 over 2. Don't include the sign. So the sign is only telling us where tan is negative. So we don't include that sign in that case. To find a reference angle, so the reference angle is going to be what? Second function of tan 1 over 2 is equals to 26,656. Then we are going to use the reduction formula or the general solution for tan. What we do to find a general solution for tan? We remember it is what? It's theta, it's equals to 180 minus our reference angle plus k times 180, where k is an element of real numbers. Now we know that we say 180 minus reference angle because that is where tan is negative. So it's negative on the, so tan is negative on that quadrant. So it's 180 minus. So that's why we say 180 minus our reference angle. So that is what we have there. Then we simplify, then we find our 180 minus 26,656, 565, it is equals to 153, 43 plus k times 180, where k is an element of integers in that case. Right. So let us now focus our attention to the second part. So this is the first part, we are done with it. Let us analyze the second bracket now. So on our second bracket, what we had, it was 3 sine 2x minus 1 is equals to 0. Then we need to separate the trig ratio to be alone. So that is the one that I'm trying to separate. Then I transpose the 1 to this side, becomes positive 1. Then we divide by 3 both sides. So we had something like sine 3 sine is equals to 1, 3 sine 2x. Then divide by 3, divide by 3. Then sine 2x is equals to 1 over 3. From here, this is the whole angle. So do not make a mistake and divide by 2 at that position. What are we going to do here? What we do now is the following. We find the reference angle. To find the reference angle here, we'll say sine function of sine 1 over 3. That is our reference. Then that is 19,43 right there. So we now going to say, remember this sign, we are saying where sign is positive. So where sign is positive, we have two solutions that we can utilize when the sign is positive. So sign is positive on the first and the second quadrant. So for the first quadrant, for quadrant number 1, we are going to now say theta is equals to the reference plus k times 360. That is for the first quadrant. Then the second quadrant, we know it is theta, it's equals to 180 minus reference plus k times 360. So that is what is happening. So this is where sign is positive first and second quadrant. So that's what we do when we are dealing with the general solution grade. So we identify where sign is positive. What tells us where sign is positive? It is the value that we had is positive. So that is where sign is positive. It is the first quadrant and the second quadrant. So on our first quadrant, we have our theta. This is our theta. So theta is 2x. So it's 2x equals the reference angle. So this is the first quadrant solution there. Reference angle plus k times 360, where k is an element of integers. Then what do? We divide by 2 throughout. Then 19,47 divided by 2 is 9,74. And k 360 divided by 2 is 180. Then we have the first solution on the first quadrant. On the second quadrant, again, sign is positive. So we need to find the solution on the second quadrant. Now, on our second quadrant, we are saying it is theta, it's equals to, we have established that nicely here. It's equals to 180 minus the reference angle. which is 19,47 plus k times 360, where k is an element of integers. Then we divide by 2 throughout. Then our x is 80,26 plus k times 180, where k is an element of integers. Now, grade 12, we have question 5.4 right there. Very nice question there. We are going to be given 7 minutes to complete this activity.